So good morning. It's a real pleasure to be here and to be able to change the tone a little bit, I think. I think we've been listening to the scientific journals. I'm going to move more into the Daily Mail area, hopefully. Snake oil, digital health. So, what is snake oil? Well, I think everybody knows, used to be sold in the Wild West. But in fact, snake oil originally was from China and possibly had curative properties. But by the time these guys got it, it was already fake snake oil. And that's going somewhere. But this isn't my expression about digital health. So this is James Madeira, back in 2016, not so long ago. Digital health being the snake oil of the 21st century. So what does this mean? And why has this come about? I think to start with, we need to look at what digital health is. And there's several ways of looking at this. One way is to see this as digitization of process and digitization of information. And what this does is, if we put all that together, really this is business process engineering. All health providers need to improve their efficiency. And as everybody knows, for various reasons, healthcare providers are having difficulties in improving some of the processes, but this is one definition of digital health. If we start looking at something a little more interesting, digitization of experience, where things are virtual reality, people using virtual reality techniques to learn how to do things, surgery and so on, or shared experiences through social media. This is where it starts becoming very interesting. Wisdom of the crowd, gathering the data from many, many people. In this case, patients are starting to become consumers. So what does that mean? So if you're a consumer, you're a health consumer rather than a patient. So you start to take control and you start to look at some of the other things that you have. But consumer health has had a fairly sad history to date. This didn't happen very long ago. Nokia came into the field and then sold out again. Adidas came into the field. We're going to digitize all the sports things that we wear, that we make. And they pulled out as well. Fitbit, some of you may be wearing Fitbits, but from an investment point of view, from a commercial point of view, doesn't look very good. That's the share price. And an analyst saying, here's the reasons for not buying Fitbit. So what is really going on here? Well, one of the reasons is this. I don't know if everybody saw this recently. Take a fitness tracker, put it on certain objects, including bananas and teacups and so on, and it'll give you a heart rate. The same happens with the Apple Watch, by the way, and other devices. So what does this mean? What is the use of this data? If it can be faked or it can just be acquired so easily. And this is from yesterday or the day before yesterday's New York Times. This company, Kinsa, nice digital connected thermometer, building up a database, and then targeted ads from Clorox. Clorox is an American bleach brand. Targeted ads and anonymized data, as claimed by the company, don't seem to run in the same sentence as far as I'm concerned. So here is the bargain. If you have your connected devices, that data's going somewhere, you need to be sure that you're comfortable with what is happening to that. Yeah, no, maybe you do. Maybe if your child's getting a fever, you do want to scrub all your surfaces with bleach. But this is the sort of thing that's happening. So where did we start down this track? Well, one of the reasons is that a lot of this stuff is being driven by the tech companies. the big fangs or so-called, but the tech companies in general. So, what does a young Californian think a patient looks like? Well, here are some ads from wearable tech and other things that have been produced in the not too distant past showing patients. So I think any patient looking that good is probably not very ill. So what does a real patient look like? They're real patients. Not very pleasant a lot of the time. So this isn't just gratuitously put up there. I put that up there because wound care is extremely expensive. Spent or costs nearly as much as cancer to the NHS. And yet here is something that people don't talk about because it's not very nice. And people who have these chronic wounds take a lot of caring for, they smell, and it's not very pleasant medicine. But they are people who need care. So, let's move on. Doctors and nurses. Anybody who's in this game would know that these are the kind of pictures that people like our company put on their websites. These are the doctors and nurses using all our things. Are they doctors and nurses? Well, they come up again and again. They're all models. Nice looking people, but all models. So what do real doctors and real nurses look like? Absolutely. Any doctors and nurses in the hall know this. Any people who have any contact with the frontline staff in the NHS or hospitals know this. So the problem is that most of the tech developers don't actually see people who use the equipment. It's being sold to the consumers, but remember there's a set of difficulties there. So what are we going to do about this? Well, to continue in this way, it came about because so much of the tech community was brought up on this kind of thing. So Star Trek. So Star Trek is real. This is what the future's going to look like. So where's my tricorder? It's like, where's my jetpack? Where's my tricorder? And in fact, there was a big X prize, $10 million, to build a tricorder. But I would argue that that was a wrong approach. The tricorder kind of exists, but it's not a thing. It's not a thing. It's an arising property of putting things together. So this is the way we need to move. And indeed, today, we're talking about exactly this. Not things, but putting data, information together, seeing new insights. So, another definition of digital health. So, digitization, not of process, but digitization of content. And we've just heard about this in terms of genetics, but what if we start looking at what we look like as people, as organisms? What about the physiognom? And I would argue that in terms of digital health, this is the truly disruptive step. What we need to do is digitize us. We need to create data-rich, dynamic digital images of what we are as physiological beings, as much as anything that's going on in the genome. So let me ask you a couple of questions. So, this clock is stopped, but it's extraordinarily accurate. I think everybody knows this, but how come? Well, it's accurate twice a day. Extraordinarily accurate twice a day, but absolutely useless as a timepiece. So, what are these numbers? Human body temperature, right? Well known. What are these numbers? Normal blood pressure, well known. You want to sit in a normal region there. What are these numbers? Normal heartbeat. So here's the question. Are these numbers right or wrong? Like the stopped clock, sometimes they're right, most of the time they're wrong. So it depends on time of day. This is normal body temperature. For a normal person, about a 2-degree fluctuation on a circadian rhythm. So it depends on that. It also depends on your age. All variability in the body reduces as you get older. So younger subjects have a larger spread. Older subjects, you start to reduce your variability. It also depends on what you've been doing and where it's measured. So here's 3 measurements of core body temperature in the esophagus, intestinally, and rectally, and they're different. Same subjects, and this is working through an exercise routine. So you see maximum VO2 max there, highest temperature, and again, there's a significant change in the body temperature, core temperature. And then this is another very well-known phenomenon. This is the ovulation spike in females. But look at that. It's only about 0.6 of a degree, 0.6, 0.7 of a degree, and that has to be found within all the other modulated temperature variations in the body. That's why those techniques for measuring fertility are so difficult. So trying to find these things, how do we move from here? Well, it turns out that not only are these kind of physical vital signs changing, everything is changing on a circadian basis, among other things, but there's temperature, blood pressure, cortisol changing, over 100 rhythms in the body. So you have a diagnostic instrument and it can measure to 5 decimal places, but without knowing when, how, some contextual information, it's really not very useful. So what does this lead to then? So we start taking things accurately. We take a couple of data points, and yes, as we see over there on the left-hand side, person looks normal. But if we start looking at something continuously or with much, much greater granularity, you start to see trends and you start to see something happening that you didn't pick up before. And so we have to look continuously and we have to start looking more closely. So here's 2 subjects, 65 beats a minute as measured on their Fitbits. Let's have a look more closely. So there's the top subject. So this is instantaneous heart rates. And the bottom subject. Which one of those is the healthy patient? Top one. Natural variability in the heart rate. This patient has got sleep apnea. This is the response of the heart in association with somebody who's suffering from sleep apnea. So these kind of regularities that we see are actually pathological generally. So we really then need to start looking at the data, and we need to start looking very, very closely at the data. And so what we need to do is come back to this idea of digitizing the patient by measuring, and if we can measure and we can measure accurately and continuously or semi-continuously, we can start to build models. And from those models, we can start to predict. And by predicting, it allows preventative action to be taken. And that action then can come back and be used to close the loop. Most of the people in this audience would recognize that as a control loop with negative feedback. Most of the doctors I speak to don't necessarily see it in that way, but that's exactly what they're doing. Interestingly, note this. Doctor in the loop. Absolutely critical. Doctor or nurse in the loop. That is the key aspect of care in all cases. Why is that? Well, one reason is that one of the most successful drugs of the last century was the placebo. We heard just a couple of weeks ago results of a trial, many people with chronic back pain, given a super new drug, control group given a placebo. The ones on the super new drug, some of them got out of their wheelchairs and felt great. Both groups were on placebos. Interestingly, when the non-control group were told that they were taking placebos as well, they still maintained their improvement. So there's a large psychosomatic element in all care, So doctor in the loop is very important. So these kind of systems that we're talking about, automated data collection systems, machine-assisted learning for healthcare providers. And this is what we do. I'm not going to talk a lot about our technology, but at iStances, we have built the patient status engine, which is a data collector and connectivity system for collecting continuous multiple vital sign data. Not a new idea. Other people do similar or bits and pieces of this, but what we've done is made it usable and affordable and scalable. So it has smart wearable sensors. These are connected to local units in a hospital configuration. They're bedside units, wireless tablets by the bed. They're then connected into a back-end system where all the data is aggregated. So what we're doing there, we're really starting this idea of digitizing patients. And it's starting to be adopted in many hospitals. Not so much in the NHS, because we could talk about why it's difficult for adoption in the NHS for a long, long time, but certainly in a number of other countries. And we're working across several different areas. So the first thing that we're looking at here is how do we address patient safety issues with the care teams in the hospitals? Because this year, about 12,000 people will unnecessarily die of avoidable deaths in NHS hospitals. No political edicts are going to change that. The people in the hospitals, the doctors and nurses are trying hard, the managers are trying hard, but that is what will happen. Because patients really just aren't being monitored carefully enough, among other reasons. But knowing what is happening to a patient, you can work against some of these things. So what are the clinicians and the nurses using at the moment? They're using something called an early warning score. And an early warning score, I don't know if anybody's familiar with this, but this is a way of taking observations, writing them down, or possibly keying them into a tablet, and weighting them according to whether they're within or how far away from a supposed norm they are. And then these things then create escalated actions. So this is really simple. Those data points might go in every hour or every 4 hours or whatever, but it works. These have had enormous impact on the reduction of mortality in many, many hospitals and the reduction of adverse events, of which there'll be about 1 million this year in the NHS, by the way. So how can we help? How can the sort of things that we have been working on at iStances, how can we help the care teams? Well, first of all, we can automate that process because we're collecting the data, so we can do that. But we can also do some smarter stuff. And we can start looking at these things which we could call digital biomarkers or data-driven biomarkers. And this is some work with hepatology patients. This is a paper about to be published. Loss of heart rate variability is a predictor for decomposition, or in that case, some deterioration of the patients with advanced liver disease, and a 90-day mortality indicator. What we're measuring here is really an aspect of the autonomic function in the body. And the 90-day thing is interesting because the hepatologists always knew out of a cohort of patients at a particular level of the disease, half of them were going to die, no matter what they did on their current care pathways. They just didn't know which half. And now there is an indication which half may not or will not make it under current practices. So that's kind of interesting. Also interesting that this study, we were doing this about the same time at the Royal Free Hospital as Google DeepMind was doing the work there. And they were working with nephrology patients, patients with kidney disease. We were working with the hepatologists with, slide's got a bit odd, but with liver disease. And so we were looking to see if you could predict what was going to happen to individual patients. And certainly we were able to do that, as indeed was the other approach, taking masses of big data. But to what I was saying earlier, what we are trying to do is make this approach, quantitative physiology, affordable and practical. And I'd argue that the way Google was doing it there, or DeepMind was doing it, isn't that. Certainly not at the moment. And here's some other really interesting work. And this is the beginning of something which we are going to see as the future. And this is a new way of being able to run an early warning score. The problem with thresholded early warning scores, not everybody fits into the thresholds. And that's particularly a problem with children. So this was work done at the Birmingham Children's Hospital, and we were looking at a lot of children. There was a training set for this new system of over 100,000 hours of continuous data. So what this does, it's personalized and it's self-learning. So it takes a new patient and determines where that patient is sitting against what has been learnt from the training set. At the moment, it's not self-generating in the sense that each new patient doesn't add to the sum of the knowledge just yet, but we can run it in batches so that every 100 patients or so can be used to generate or update this neuroscale output map. And so what we're seeing here is the first, and I believe this is the most sophisticated, real-time AI system for physiological monitoring. And this has been great. It's been shown to be more predictive than their current PEWs, their pediatric early warning scores. And the real challenge here was how to present this data in an intuitive way. How do you bring something together that turns out not to be like a linear progression? So the score there isn't just something that goes from 0 to 10, because that's not the way patients move within this kind of phenotype space. People wander all over the place. So how we're presenting it at the moment is as a heat map with a patient who is represented by a large dot, the dot size being associated with how long the patient has been sitting in a particular region, and then that moves around either away or closer to a region of higher risk. So we're testing that now with outside of the research work that was there, just running it with the ward staff to see how they work with that. So I think that's a really interesting example of where these kinds of digitized systems are going. And so just a few predictions then. Digitized connected patient is coming. So in 10 years, I believe patients in hospital, because the first thing this technology does is take all the cables and wires away from patients who are in bed, They don't need to be in bed anymore. They can be continuously monitored with almost ICU-grade monitoring by being fully mobile. And it's going to happen. Everywhere else has gone wireless because it's cheaper than running cables and wires. But it's going to create a lot of data. It's going to create a lot of data. And when that data is available and converged with the other work that we've been hearing about in this conference, we're going to see a real change in the way clinical care can be practiced. So that's the end of my talk. Thank you.
Thank you very much, Keith. We have 5 minutes for questions to Keith. If you could wait until you're given a, what are those things called? A talking into thing before you ask your question, then it will get recorded. And wave to me very well if you can. Any questions in the room? We'll have this one then.
I'm Susan Graham, and this is a question which I hope will not upset anybody. I really appreciate your lecture, but in the lecture, is there a way or method which could be digitized that departments can talk to each other so that they're not giving away very confidential information, but they will be able to transmit or transfer information which would be useful to another department in the same place or otherwise? And thanks for listening.
In a clinical context, you mean? Well, there are attempts to do that by so-called ICD-10 codes and so on, which is a way of trying to standardize descriptions of diseases and treatments which allow that kind of information to be passed. It doesn't necessarily need to be associated with an individual patient or personally identifiable data on the patient.
Thank you very much. Further questions for Keith? Yes, please.
As you were describing your work, I wondered whether there will be any normal people around. I mean, how will anybody feel healthy for a substantial amount of time?
I think that's a really interesting question because the more, my background is physics and I'm used to hard sciences, but the more that I find out about human physiology, the less normals there are. And we don't even know what would define normal in that sense. Also, because of this whole thing about variability in the body, it has been argued that medicine as it is currently practiced can only be practiced because that variability reduces as we get iller, as we get sicker. If we didn't sort of come back to some kind of more like normal, the sick people are the normals, if you like, then it'd be very, very hard to treat a very well individual. But one of the things that we will find out, I believe, by these kind of big digitization programs, we will learn more. And I'm not saying to people throw your Fitbits and so on away. That technology will improve, and this data will start to be collected. But there is a devil's bargain there, remember that as well.
Question, I'm going to take that one there, if that's okay.
Greg Judge, Anthony Nolan. Patient outcomes data is really important for researchers as well as clinicians. But in terms of accessing the full potential of that data set coming out of a clinical unit, is there potential for technology in the future to curate the outcomes data and provide it for researchers without having an additional impact on clinical time for people to review data before they can send it out?
So your question was, can the patient or can there be other?
Technology or patients help to curate the data instead of having a larger demand on clinicians' time to review data before it goes out?
Absolutely. I think that is one of the things that could be done, and I think that data set, curated or otherwise, but certainly a secured repository for the data set that wasn't Google or Apple or somebody like that, is absolutely necessary. And the development of techniques which can anonymize that data It's very hard to anonymize any data these days, of course. You know, you might take the name of somebody, but 5 minutes on a Google search and you can usually sort of find out enough to be pretty sure who you're talking about. So, but those big data sets, yes, should be put together. And I think the 100,000 Genome Project needs something like the 100,000 Physigenome Project to go with it as well.
Keith, thank you very much indeed. Will you join me in thanking Keith?